Hi guys. So I hope you guys are ready to move ahead with finding the determinant of a 3 by 3 matrix. Woo! All right guys, last video you would have seen me find the determinant of a 2 by 2 matrix, and it was pretty simple, pretty straightforward. Finding the determinant of a 3 by 3 matrix also is pretty straightforward. It just has a couple more steps. Yeah, you guys are gonna ask me about those couple more steps. It's a lot more, but it's easy. Trust me, it's really easy. So when you're finding the determinant of a 3 by 3 matrix, you kind of have a little longer method ahead of you, and it goes like this. Let's get into it. So our 3 by 3 matrix, as you see on screen, I have denoted all of my letters by their locations in the matrix. So for example, if I just pick randomly, this one in the middle here, A sub 22, that belongs to row 2. All right, that belongs to row 2 as well as column 2. And when we're ordering or naming a matrix, we call it according to its row, then its column, or row by columns. So it's a 2, 2. So that's why it's called A sub 2, 2. All right. Now, right, with that said, what we want to get into right now is how we arrived from our original matrix into this formula. Now, it looks complicated, but I'm going to tell you guys. All you need to know is how to correctly label all of your numbers in your original matrix using those letters and subscripts. Once you have that down, this formula is totally a breeze. Trust me. Look how simple it is. So what you want to focus on in moving from your original 3 by 3 matrix into your equation is by first selecting or highlighting that first element there, A11. Now you want to start with your formula using this element. So your formula will begin by A sub 11. And then you'll notice right after we have the determinant sign, and then we have 4 of those elements inside. Now, how did we generate which elements go inside? Very simple. You see A11, it belongs to this first row and this first column. So what I'm going to do is I'm going to cross it out. And you guys should notice that, hey, the leftovers are actually what's written down below. We have 2, 2, 2, 3, 3, 2, and 3, 3. Check right here. So essentially, once you are highlighting a particular element, you eliminate all of the others in that row and column that belongs to, and the remnants, what's left back, is what you write within your determinant sign. And that's how you get your first part of your equation or formula, whatever you want to call it. All right, so let's go back. Let's erase some of those good stuff there. All right, so now we want to find out how to get this part. Now, it's the same story. The only thing you need to remember is that to create the second part of this formula, it always has a minus sign. So take note of that. So it's like plus, minus, plus. It's a 3-part formula that you are creating here. All right, so I'm gonna just take those away. And now we're gonna get into it. So similarly, we have this second element here. We're gonna highlight it. And we're gonna once again eliminate everything that belongs in the same row of that element, as well as eliminate everything that belongs in that column of that element. And guess what? What do we have remaining? We have A sub 21, check. We have A sub 23, check. We have A sub 31, check. And we have A sub 33, check. So essentially what you're doing is eliminating the row and column that your number, letter, sorry, outside belongs to, and you're just writing in everything else that remains. The remnants, I call them the remnants. All right, guys, so let's do this for our last and final part of our formula, and let's begin trying some questions. So lastly, you choose your last element of your first row. And once again, you eliminate everything that belongs to that row and column. And you're going to end up with A21, A22, A31, A33. Oh, and I see I made a boo-boo. So it's good to check that I made this boo-boo here. This is supposed to be 32. Let me change that. Okay. Actually, I changed it after. So let me just, actually, I'll leave it. Yeah. Oh, that's a big eraser. Taking away so many good stuff, you are, eraser. Okay, looks good. It looks good, guys. So, it was a good check to make sure that you don't make mistakes like me, because, you know, mistakes happen, guys. It's just a natural part of life. Don't beat yourself up over it. I don't. Okay, so this is how you arrive at your general formula for finding the determinant of a 3 by 3 matrix. So let's get into its application, shall we? Let's take a question here. Draw a pretty line. I don't know about you guys, but I really enjoy maths. I have always been, since I was a student, I've always made tons of mistakes. Like you guys can see on screen, I make lots of mistakes. But you see the concept, maths is a whole conceptual idea. And once you understand that, then you actually know what you're doing. Mistakes are just, you know, they happen. And mind you, when people are marking questions, there's something called error carry forward, where this holds for if the person understands the concept, they understand the method, they are able to apply. I know my writing makes no sense, but pretty much if you understand all of those three things, then your calculations just typically go for 1 or 2 marks, because I mean, the ability to use a calculator is just, you know, the calculator is doing the work there. So kudos to calculator for working out the final answer. All right. But I'm not a robot and I make mistakes. That's okay. All right. So we're going to look at an example so we can apply this formula. Actually, I'll leave the formula on screen so you guys, actually, no, I won't leave the formula on screen. Let's see how easy this actually is to do. If we're given a matrix A, I don't know, let's just say it has values. I want to use one that has negative values. Let's use 1, -2, 3. Let's throw in a 0 there. 1, 4, and 2, 1, 2. Okay, great. So this is a 3 by 3 matrix. Check. 3 rows, 3 columns. It's a 3 by 3. Now, because it's a 3 by 3, we cannot use the 2 by 2 process to find the determinant. So we have to use the 3 by 3 process. Okay, so we're going to find the determinant of this matrix. Now, if you can recall, the determinant of a 3 by 3 matrix is given by a special formula. But formulas are so arbitrary, man. We're going to use what we remember. Okay, so according to our formula, it says to use that first number. So I'm going to kind of circle it. All right. And next to your first number, you're going to have to find the determinant of the remnants. So that belongs to the first row and first column there. So the remnants would be 1, 4, 1, 2. If you want to see it, I'll do the cross out. So we have 1, 4, 1, 2 remaining. Check. So I'm going to undo that. All right, so let's go again. Now to get the second value, I'm going to highlight this. Now remember, the formula goes plus, minus, plus. So this is supposed to be a minus. And then the value we're actually inputting happens to also be negative. So take note of those sign changes. And then what are our leftovers here? I'm seeing 0, 2, and I'm also seeing 4 with 2. Let's check if that's correct. So if I cross out all of these and all of these, then I'll get 0, 4, 2, 2. Check, that's correct. And then lastly, it's going to be a plus. The last element of that first row by its remnants, and I'm seeing the remnants will be 0, 1, 2, 1. Let's check if that's correct. Cross out everything from the row, everything from the column, and yes, we do have 0, 1, 2, 1 remaining, so that's a go. And this is how you apply finding the determinant of a 3 by 3 matrix. From here, you would actually have to find individual determinants. So you would have to find the determinant of this mini matrix, which is a 2 by 2. So that will give us 1 multiplied by 2 is 2, subtract 4 times 1. That's 4. And subtract by subtract gives us a plus 2. And we're going in at it again. 0 multiplied by 2 gives us 0. Subtract 4 multiplied by 2 gives us 8. I'm using square brackets. You could use curved brackets if you wanted. Find a determinant. 0 by 1 gives us 0. Subtract 1 by 2 gives us 2. Putting all these things, you can put this into your calculator straight away if you wanted to. You can work it out like I am working it out on screen. But this value works out to be negative 24. Okay, guys, so this is how you would find a determinant of a 3 by 3 matrix. And take note that one of these values can actually be an unknown. Say it could have been x. And similarly, they could have said that this matrix is also singular, find the value of x. And if that was the case, you would have just simply had to equate whatever you got to 0. If you would like to see some examples of questions like that, please post a comment down below in the video, and I will be sure to include tutorials involving questions of that form. Now, I just want to highlight some special things that might interest you guys and make you guys go, ooh, that's pretty cool. So here's some properties. Here's some fun facts, right? Some fun facts, man. Some fun facts of determinants. All right, so guys, you wouldn't notice this, but one of the cool features of finding determinants is if you have every row or column, it doesn't have to be both, right? If every element of a row column, right, every single, I should write that there, if every element, sorry. If every element of a row or column is 0, then guess what? Automatically, the determinant of that matrix is 0. So just to take note, if, for example, if we had a simple 2 by 2 matrix here, and we had this case scenario taking place where we have the first row, the entire first row is all zeros, then the determinant of this matrix is automatically equal to 0. Cool, huh? Similarly, it can happen for if you had all the columns of a matrix. It doesn't have to be a 2 by 2. It could have been a 3 by 3 matrix, 4, 5, 6, -1, right? So it doesn't matter what type of matrix. Once all the rows, all the elements of the row or column are 0, then its determinant is equal to 0. That's a fun fact. And also, more fun facts. If 2 rows or columns of a matrix are identical, then its determinant is also equal to 0. Cool, huh? So check this one out. So for example, like if I have 3 by 3 matrix here, and I have this going 1, 2, 1, 5, 0, 9, 1, 2, 1. We have over here, we have row 1, and we also, sorry, column. It's a column. We have column 1 and column 3. They're containing the exact same values, right? They're identical. So in this case, if we had to work out the determinant, it's automatically equal to 0. So sometimes you can get questions pop up like this in exams, and instead of spending an exorbitantly amount of time doing this, if you see it, then you can just simply write down your answer. Of course, giving them some form of explanation where you recognize that 2 rows or 2 columns were identical. So therefore, you know that the determinant is equal to 0. Okay, so those are some popular and very interesting fun facts about determinants of matrices. I hope they will help you in solving any question that you encounter, and I look forward to you guys continuing watching my videos. Please share to anyone you know who is writing exams coming up in 2 months' time and have not covered this topic as yet. And of course, if you guys want to see those tutorials, I'm going to try my best to do all past paper questions as possible, where I write on screen and I keep it real as if you're in a live classroom. Okay, guys? So much love. Stay safe. Remember to always give to others as much as you can. Share, help somebody out. And I look forward to being with you in next class. All the best. Bye.